Okay, welcome back to another video on the Maths channel. It's your teacher Mr. Lim here, and in this video we're going to be looking at bearings. Now bearings are used to communicate direction and therefore are important in navigation. Ship and aeroplane pilots, bushwalkers and military personnel all use bearings to navigate and communicate direction. By the end of this lesson you'll be able to identify the bearing of a point from another point and use your understanding of bearings to solve trigonometric problems. So let's have a look at the first part of this video, identifying bearings. Now there's two different types of bearings. The first one that we're looking at will be compass bearings. Most of our test questions won't be on this one. They'll usually be on the true bearings, but it doesn't hurt to review this. So compass bearings always have to do with north, east, south, west. So we're going to be having north some angle east or west, or south some angle east or west. So if we're trying to find the compass bearing of this angle here for the first question, because this arrow is in the northeast section, I'm going to write northeast, but I need my angle. So because I started from north, I need to work out how many degrees from north is the angle going east, which means from north, how many degrees east is it going? We know that this is 30, so 90 minus 30 is 60, so this has to be north 60 degrees east. In the next question, I'll just complete this compass rose. We know that this line is in the southwest. So I'm going to write southwest, but I just need to work out how many degrees is it from south to west. So from south to west, I need to know how big that angle is. So if I were to do 90 minus 23, I'll get 67 degrees. Alright, let's have a look at true bearings. When determining the bearing of one point from another, you need to remember the word from is very important, because that is where you start. If there is no compass rose with the cardinal directions north, south, east, west, then you have to draw it. You must always start at north and move in a clockwise direction. Bearings are written with 3 digits. Opposite directions differ by 180. So if one of the bearings is less than 180, just add 180 to it to get the opposite bearing. And if one of the bearings is more than 180, minus 180 from it to get the opposite bearing. That way you don't really need to draw it. So let me give you an example. For each of the diagrams shown, write the bearing of A from O and O from A. So let's have a look at the first one. It says A from O, which means we're starting at O. North of O in a clockwise direction until we hit the line that's connected to A. So this one is 0, 4, 0 degrees. Nice and easy. Now for part 2, we want we want O from A. So we're starting at A, north of A, in a clockwise direction until we hit the line. Now, according to alternate angles and parallel lines, here's our alternate angles. This bit here has to be 40 as well. So the bearing has to be 180 plus 40, which is 220 degrees. Now, if you don't want to draw that, if we have a look back at the notes, opposite bearings differ by 180 degrees. Because of part 1, we found that the bearing of A from O is 040 degrees, which is less than 180. All we had to do to find the opposite bearing, O from A, is to add 180 to it. And that's what we did here. 40 plus 180 is 220 degrees. I'm going to have a go with question B and C as well, and then I'll get you to pause the video so they can try the next few questions yourselves. So, part 1, A from O. So we're starting north of O in a clockwise direction until we hit A. So that means that the bearing has to be 180 minus the 38, because this is 180 minus that little bit will give us the bearing, which is 142 degrees. Part 2. Because this is less than 180, I'm just going to add 180 to it. 142 plus 180 is equal to 322 degrees. Question C. Part 1. A from O, we're starting north of O, clockwise direction until we hit A. We know that this bit is 30 degrees, so it has to be 180 plus 30, which is 210 degrees. However, when we're finding the opposite bearing, O from A, because this is more than 180, we're going to minus 180 from it. So it's going to become 210 minus 180, which is equal to 30 degrees. Sorry, we need 3 numbers, 3 digits, 030 degrees. Okay, so now I want you to pause the video, have a go with question D, E, and F. Find the bearing of A from O and O from A for each of them. And when you're ready to check your answers, I'll get you to continue playing the video. Okay, so for question D, part 1, we're finding A from O. So from north of O, clockwise direction until we hit the line. We know that up to here is 270. So 270 plus 18 is 288 degrees. Therefore, part 2, O from A, I'm going to minus 180 because it's over 180. That gives us 108 degrees. Okay, part 2. Sorry, part E. Part 1 is 90 plus 35, 125 degrees. So part 2, we're going to add 180 to it, which is 305 degrees. And part F, $90 minus 23 is equal to 67, so 067 degrees. And part 2, because that's less than 180, I'm going to add 180 to it, which is 247 degrees. Alright, so now that we know how to use bearings, we're going to apply our understanding to trig problems. So a bushwalker walks 3 kilometers on a bearing of 60 degrees from point A to point B. How far east, correct in 1 decimal place. Find how far east point B is from point A. So here's point A. This is walking on a bearing of 60 degrees. So from north, 60 degrees might be around here, to point B. Find how far east. So we need to work out x, how far east point B is from point A. And I just need to put in that 3 kilometers. Okay, so here we've got a right angle triangle. And now we can use SOHCAHTOA. Okay, we're going to label the triangle. We've got the hypotenuse, we've got opposite, so we're using sine. Sine of the angle, 60 degrees, is equal to opposite over hypotenuse. And we've got the number in the in the denominator, bring it out to the front. 3 sine 60 is equal to x, so x is equal to 3 sine 60, 2.60, 2.6, 1 decimal place, kilometers. Okay. A ship travels south for 5 kilometers, then on a bearing of 120 degrees for 11 kilometers. So it travels south for 5 kilometers, then on a bearing of 120 degrees for 11 kilometers. Find how far east the ship is from its starting point. So we need to work out how far east. We'll call that x. That's what we need to work out, how far east it is. Well, that's 120. This has to be 30 degrees. And now we can just label the triangle. We've got the hypotenuse and we've got adjacent. So we're using cos. Cos of the angle, 30 degrees, is equal to adjacent over hypotenuse. Bring it out to the front, 11 cos 30 is equal to x. So x has to equal to 9.53. Kilometers. Alright, so that's question A. Question B says, find how far south the ship is. So we need to work out what this is. Let's call that y. So we've got the hypotenuse. We can label this one opposite. Therefore, we've got sine. Sine of the angle 30 degrees is equal to opposite over hypotenuse. Therefore, bring that out to the front. 11 sine 30 is equal to y. So y is equal to 5.5. However, the ship started here. So we need to add 5 to the 5.5 to work out how far south the ship is from its starting point. Therefore, ship is 5.5 plus 5, 10.5 kilometers south of its starting point. Alright, last question. I'll get you to pause the video, have a go yourself, and then you can continue with the video to check your answer. Alright, so Chris walks 5 kilometers south, then walks on a bearing of 36 degrees. So 5 kilometers south, and then on a bearing of 36 degrees, until he is due east of his starting point. How far is he from his starting point to 1 decimal place? So he started here, he finished here. That's why I've labeled that line X. So let's label this triangle. We've got opposite and adjacent. That gives us 10 of 36 degrees is equal to opposite over adjacent. Therefore, 5 tan of 36 is equal to x. So x is equal to 3.6 to 1 decimal place. So now you should know how to find the bearing of any point. So using the compass bearing or a true bearing, and now you know how to apply that knowledge to solve trigonometric problems. And that's all for this video.